Where does energy come from in object geometry? Automatic translation from the Polish language. The answer to this question is the property of consolidating the energy accumulated in the actions of possibility M, the center O, in spacetime, limited by the boundary conditions of the object. Properties, consolidation, and superposition explain in simple terms many physical phenomena. The following assumptions and definitions were adopted in object geometry. 1. An object is a spacetime bounded by boundary conditions. 2. There is an O-center common to all facilities. 3. The O-center is an unlimited spacetime collection of information about the operation of the M capabilities of all objects. 4. The actions of the O-center in the object's spacetime travel at the speed of light. 5. The actions of the center O limited by the boundary conditions of the object have the property of consolidation and superposition. 6. Consolidation is the source of energy for the activities of the M capabilities of objects. 7. Superposition determines new objects by instructing them to operate their M abilities and the energy from the entangled object. 8. The operation of an object's M capability is determined by instructions and energy transferred to it in a superposition from an entangled object, energy accumulated in it as a result of consolidation, energy obtained as a result of interaction with other objects. 9. An object of the entanglement type collects information about the action of entangled possibilities M of objects. 10. Entanglement limits the effect of an object's M capability as stated in the entanglement instruction. Assuming the above assumptions, we will define the methods of storing and transferring energy in facilities and between them. Energy is continuously provided by the consolidation activity and stored in the M capability activities of objects. The impact of consolidation is proportional to the amount of energy stored in these activities. We experience it as the action of gravity. In the operation of an object's M capability, a different amount of energy may be stored. The object with the lowest energy is 1 quantum. Its boundary conditions limit the O-center, 300,000 kilometers in diameter on our scale. This is due to the formula E equals h times c divided by the wavelength limited by the boundary conditions of the object. H is Planck's constant and is equal to the energy of 1 quantum, and c is the speed of light. As the energy stored in the object increases, the wavelength limited by its boundary conditions decreases. If the same object stores the energy of, say, 1 neutron 27 times 10 to the 23rd power quanta, it will shrink to the size of the nucleus of the atom, 1 times 10 to the minus 15 meter power. The impact of consolidation in such a small object is much greater than in an object 1 quantum of energy. It manifests itself as a strong force inside the nucleus of the atom. Suppose we want to split a neutron into 2 equal objects and move them apart by a distance of 10 to the minus 55th meter. The potential energy resulting from their mutual gravitational attraction will be comparable to the energy stored in them. The continuous increase in energy due to consolidation would cause the object to collapse into zero singularity. Object geometry does not allow null or infinite singularities. Such singularities do not have boundary conditions. They do not meet the definition of an object. The facility will maintain stable boundary conditions if it is able to transfer excess energy accumulated as a result of consolidation to other facilities. An example of a stable object is an atom of type. It consists of a proton-type object, which is its nucleus, an electron-type object, an electric field-type object, and its entanglement-type object. The energy supplied by the property of consolidation is mainly stored in the nucleus of the atom. The accumulated energy discretely changes the operation of its M capabilities. Between successive energy levels, energy accumulates in its object like entanglement. Let's go back to an example neutron object. If the consolidation action stores 939 megaelectron volts in it, then in about 15 minutes, the effects of its M capabilities will change. The result will be superposition of a proton-type object with a positively charged surface, superposition of a new electron-type object, superposition of a new electron-antineutrino-type object. In a proton-type object, a state of equilibrium is achieved between the energy produced by consolidation and its dissipation by the positive charge on the proton surface. It uses energy to counteract collapse as a result of consolidation. Under favorable conditions, a stable object, such as a hydrogen atom, may also be created. It consists of a nucleus, which is a proton-type object, and an electron shell composed of an electron-type object, an electric field-type object, and an entanglement-type object. Between the positively charged nucleus and the negatively charged electrons, a new electric field-type object is created as a result of superposition. The operation of its M capabilities varies discretely depending on the amount of energy stored in it and in an atomic entanglement-type object. The change between the discrete energy levels of an electric field-type object is accompanied by a superposition, the emission or absorption of an electromagnetic field-type object, also known as a photon-type object. The electric field object also allows energy to flow from the positively charged nucleus to the negatively charged electrons as a result of the attractive interaction between charges of opposite signs. Electron-type objects can merge into larger objects thanks to the consolidation action. Consolidation then becomes a weak impact. It connects atoms into larger objects such as chemicals and crystals. Electron objects can also transfer energy if they are entangled with an electric field object. As a result of such entanglement, positive and negative charges appear at the edges of the electron cloud. In between, energy can be transferred at the speed of light. An example of such an energy flow is electric current. If an object receives a lot of energy, it begins to tighten its boundary conditions, moving them away from the nucleus of the atom until it is completely exposed. Then the phenomenon of ionization takes place. If the electron object is not entangled with the electric field object that supplies it with energy, the electron object spends its energy on the repulsive action of the negative charge, as long as its boundary conditions are able to hold it. It is then superposed to a new neutrino object. The neutrino object has no electric charge. The remaining energy in it expands its boundary conditions. It becomes much larger compared to the nucleus of the atom. It can therefore move between the nuclei of atoms without creating tangles, i.e. without interaction. The neutrino-type object does not have an electric charge on its surface. The increasing energy as a result of consolidation causes it to collapse. After reaching the energy of a neutron-type object, it undergoes superposition, resulting in the formation of objects such as proton, electron, and antineutrino, creating a new hydrogen atom. In a large object such as a star, under conditions of high pressure and high temperature, the nuclei of hydrogen atoms will ionize, losing electrons, and remain proton-type objects. The consolidation of neighboring objects is added to the consolidation action inside them. Protons under such conditions gain weight faster. Deprived of electrons, they will not be able to dissipate the energy produced by consolidation activities. Increasing energy changes the operation of their M abilities. By changing them into deuterium, tritium, helium nuclei and objects such as electron, neutron, neutrinos and photons. Part of the energy will increase the kinetic energy of the nuclei, increasing their temperature. If the kinetic energy is sufficient to overcome the potential barrier of positively charged nuclei, they will be able to merge into a larger nucleus to form a common proton-type object with a positively charged surface. The nucleus will be formed in the process of thermonuclear fusion, which will further accelerate the formation of increasingly heavier nuclei. As a result of accumulating more and more energy in the nucleus, the accumulated positive charge increases on its surface. This happens as long as the force it produces does not exceed the consolidation force. Then the nucleus will be divided into fragments with less energy and a larger area. This phenomenon can be common to atomic nuclei as well as to supernova explosions. Due to consolidation, objects of different types can combine to form new objects, if their boundary conditions allow them to do so. On the other hand, the electric charges generated on the surfaces of objects prevent them from collapsing to zero singularities. For this activity, they use some of the energy generated by consolidations. The above-described storage and transfer of energy generated as a result of consolidation in objects and between them explains many phenomena based on the assumptions of object geometry. What is mass? How objects